All right, here we're looking at section 11.4. And so my learning targets for today are first we're going to be describing experiments. Then we have to recognize how randomization applies to experiments and observational studies and kind of what the difference is there. And then we're going to analyze some experimental design. So the first thing is we're looking at some experiments. When we're describing and when we're making an experiment, we always want to have a controlled experiment. So in a controlled experiment, I've got two groups where everything is identical except one thing. And the thing that I change is I change for my treatment group. I only change that condition or that variable for one group, and that's my treatment group. The other group, my control group, I don't change anything. You've done a lot of these kind of experiments in your science classes, so hopefully this is not new language for you. So randomization is what we really look for in statistics. So when I randomize it, I can randomly assign subjects to different treatment groups. So either the control group or the treatment group, and it's a random process. And we'll look at some of these in examples. So sometimes I also have a placebo where my control group is given a pretend treatment. So it's an unmedicated treatment that resembles the actual treatment. This placebo I can use to compare with the actual treatment group, so it can help me make some determinations on the effects of the treatment. And remember from our last section, I always want to randomize my groups and where my people in treatments go, because then that will minimize the bias and will make it an actual valid study. So let's look at this first example. So I first have to determine whether it's a randomized comparative experiment, and if so, I want to describe the treatment, the group, and the control group, and if not, explain why it's not going to be valid. So here, this is supposed to actually be a V. So vitamin C lowers cholesterol. At a health clinic, patients were given the choice of whether to take a dietary supplement of 500 milligrams of vitamin C each day. 50 patients who took the supplement were monitored for 1 year, as were 50 who did not take the supplement. At the end of 1 year, patients who took the supplement had 15% lower cholesterol levels than patients in the other group. So based on this, I have to determine whether it was a randomized comparative experiment. And since these people got to pick whether or not they took the supplement, we're going to say that no, this was not a randomized experiment. Okay? So because my individuals were not randomly assigned, so the conclusion that vitamin C lowers cholesterol may or may not actually be valid. There could be other lifestyle factors or reasons why the patients who took the supplement had lower cholesterol levels. There could be other lifestyle things, so I cannot say that this was a randomized comparative experiment. So let's look at B. So to test the new design of its self-checkout, a grocer gathered 142 customers and randomly divided them into two groups. One group used the new self-checkout and one group used the old self-checkout to buy the same groceries. Users of the new self-checkout were able to complete their purchases 16% faster. So was this a randomized comparative experiment? So yes, this one was. The treatment of this was the new self-checkout. The control group was the old checkout. And I know that this was a randomized comparative experiment because I minimized the variables that I changed. They used the same groceries each time. So that tells me that I'm able to look only at the checkout speed and not necessarily the type of groceries that they got too. So here I want you to think about this problem and tell me, is it a randomized comparative experiment or not? And what else do you need to know in order to solve this? So we talked a little bit about this in a previous section, the difference between an experiment and an observational study. So in an experiment, individuals are assigned to the treatment or control group, and something changes, and we try something. In an observational study, random samples used from the groups that are being studied. So again, remember with an observational study, nothing is actually done to the people. We just kind of look and see what's going on normally. Whereas an experiment, we change something. But still, we can randomize both of these. So we can also look at causality. When we're dealing with these, we always want to look at causality. Did the treatment that I gave cause this other thing to happen? So when we're dealing with our randomized comparative experiments, if I eliminate other variations other than my controlled variable, I can make a valid cause and effect conclusion. So from our first example using the checkout lanes, I got rid of all my other variables. People were not using different groceries. It was random people. So that I could find a cause and effect conclusion. So when I use an observational study, I can identify a correlation between variables, but not a causation, because there's other things that may be affecting my results. So I want to explain whether the following research topic is investigated through an experiment or an observational study. And then I have to describe my design that I would make with this one. So the first thing is I want to know whether vigorous exercise in older people results in longer life. So the first thing you think, well, this would be a good thing to experiment with. However, forcing people, random people, to do vigorous exercise is not ethical. So I would have to say that that is not a good thing to experiment. So here I could use an observational study. So I would randomly choose one group of people who already exercise vigorously and then randomly choose a group that don't. Then I want to monitor the ages of both of those groups at regular intervals and see what I see. So because I'm using this observational study and not an experiment, I could identify a correlation, but not necessarily a causation, because there may be other factors in the longevity of life from these people. So I want you to think about this sentence and see whether or not you could do an experiment or if you just do an observational study with this one. So let's look at this example. A pharmaceutical company wants to test the effectiveness of a new chewing gum designed to help people lose weight. So we're given some scenarios, and I need to identify a potential problem, if any, with each experimental design, and then figure out how I can improve it. So let's look at A. The company identifies 10 people who are overweight. 5 subjects are given the new chewing gum and the other 5 are given a placebo. After 3 months, each subject is evaluated, and it is determined that the 5 subjects who have been using the chewing gum have lost weight. So the thing I noticed that could be wrong with this setup is I'm not using very many people. So I can't say my results are valid with only 10 people in this study. So to improve my validity, I must increase my sample size and I must actually replicate my experiment. I must have a lot more people than that. So let's look at B. The company identifies 10,000 people. So here in this problem, we fixed the problem that we saw earlier. 10,000 people who are overweight. The subjects are divided into groups according to gender. Females receive the chewing gum and males receive the placebo. After 3 months, a significantly large number of the female subjects have lost weight. Well, so here I see I'm grouping people and separating them based on their group. So it's not a randomized sample. So there may be other things involved. It could just be that the gum works better for females than males. There's lots of other things that we can say. So now let's look at C. So the company again identifies 10,000 people who are overweight, so my sample size seems good. The subjects are divided into groups according to age. Within each age group, subjects are randomly assigned to receive the new chewing gum or the placebo. Then after 3 months, a significantly large number of the subjects who received the chewing gum have lost weight. So this, to me, is our most valid experiment. So the subjects are divided into groups using their similar characteristic, but then those groups are all randomly assigned. Then I know that this is possible and it's a valid subject. So I can also replicate this and then get some more results and continue to go on. So I know that this would be a good experiment. So now here's something for you to try. See if you can, again, decide what kind of, is it a good experimental design or how would you improve it? So the first thing we did today was we described experiments. We figured out what an experiment was and how we could do some pieces of that and see what the control group was in our treatment group. Then we looked at recognizing randomization and how we can apply that to experiments and observational studies. And then we looked at several different experiments and analyzed the design and offered some improvements. So now that we've gone through these 3 learning targets, go ahead and work on the homework for 11.4.